Good morning everyone. My name is Adarsh. In our previous video we have discussed about the classification of numbers. As chapter 1 we were discussing of class 9. So now we'll move further with rational number and irrational numbers. Rational numbers and irrational numbers. First of all, we'll take some of the numbers and we will do the decimal expansions. Decimal expansions of these numbers. Okay, so here we are having some numbers like under root 2. If we will do the decimal expansion of under root 2, we will get 1.41421356 and so on. In the same manner, if we will take the decimal expansion of root 3, we are having 1.732050807756. So what you are seeing in these two decimal expansions, that we do not have any recurring or repeating numbers in both the decimal expansions. So here now we are having a definition for these two rational or irrational numbers. As in my previous video, some of the students from Kanpur, they asked me to give the definition of rational and irrational numbers. So here are the rational and irrational numbers definition. So what we find in these two, that a number which has, or else a number which decimal expansion is non-terminating and non-repeating is called an irrational number. Here you can also see that one. We have written these two irrational numbers. We can see like we are not having any terminating answer for both under root 2 and under root 3. Neither we are having any repeating or nor recurring numbers in these two. So here we are having the definition: a number which decimal expansion is non-terminating. It is not terminating and non-repeating, neither terminating nor repeating, is called a irrational number. Similarly, if we will take the example of 1/7, what we are getting as in decimal expansions, 0.142857 and 1 4 2 8 5 7 and so on. So we find out that these 6 digits are repeating continuously. So here we will be placing a sign of 0.142857 and repeating. So this seems a rational number. Next, if we are having 1 upon 2, then the decimal expansion for it is 0.5. That shows terminating. So here the definition for rational number is a number which decimal expansion is terminating or non-terminating. Here it is not terminating. We are getting the continuous answer, continuous repeating digits for 1 4 2 8 5 7. So non-terminating but repeating. So these are the definitions for rational or irrational numbers. A number which decimal expansion is terminating in this case, or non-terminating but repeating in this case. I hope you understood, everyone, about rational or irrational numbers. But here one question is there for us, like pi is irrational, because if we will move to the formula for pi, what we get? Pi is equal to circumference upon diameter. So we'll also see the answer for it, why pi is irrational. Pi, question is for that one, why is pi irrational, since pi equal to circumference upon diameter. So the answer for this question is, as we are measuring from a tape or a scale, we only get an approximate values of our measurement. But as mathematical fact, pi is irrational. So we'll write down the same one here as on a measuring scale or measuring tape, we only get an approximate. Remember this one? Approximate values of our measurements. But as mathematical fact, fact pi is irrational. Pi is irrational. Why? Because pi value is 3.1415926535897932 and so on up to trillion decimal. So if you will see the value, we are getting neither repeating nor terminating, which is actual value of pi. So in this manner, pi is irrational, which shows neither terminating, because it is continuing with the answer up to trillion decimal. So neither it is terminating nor repeating. That's why pi is considered as rational number. Irrational number. That's why pi is irrational. Consider that answer. Next. Either we are having rational number or else we will be having irrational number. Both we can locate on a number line. First of all, we'll do the revision how we are locating the rational numbers on a number line. So suppose if I will take 2/7. If we want to locate this rational number on a number line, what we are using? Suppose this is our number line. It is 0, -1, it is +1, +2. So what we are seeing, this fraction is less than 1. So the rational number will be in the middle of 0 and 1. So we are seeing the denominator first. What is there? 7. So we will do the 7 equal part between 0 to 1. So 1, 2, 3, 4, 5, 6 and 7. So this is the 7th part, which is 1 for us. So 1, 2, 3, 4, 5, 6 and the 7th part. And we need to consider the part of numerator, which is 2. So this is R2/7. So in this manner we are locating the rational numbers on the number line. But now the question is here, how we are going to locate the irrational numbers on the number line. So we are having some ways to locate the irrational numbers on a number line. First of all, we will consider this way, which is very easier to understand. So what are the irrational numbers? First we must know irrational numbers, like example √2, √3. These are the rational numbers. Now we have to locate them on a number line. So how we are going to locate them on a number line? If you want to locate these irrational number on a number line, first we must know about the Pythagoras theorem. Pythagoras theorem. In this Pythagoras theorem, what we are getting? Hypotenuse square is equal to perpendicular square plus base square. And this theorem works in a right angle triangle. Right angle triangle means one angle must be 90 degree. So here it shows the base. This is perpendicular. And this is hypotenuse. This is hypotenuse. So in this right angle triangle, it is going to work. Using this Pythagoras theorem, we are going to locate under root 2 and under root 3 on the number line. Suppose this is our number line. Here we are having 0. This is minus 1. This is plus 1. They both will be the unit 1. Understood? Not having a fixed measurement, but we can say like we have supposed it as unit 1. So as if we will take our base as unit 1 and we'll take the perpendicular 2 as unit 1, this is unit 1 and this is perpendicular is also unit 1. Then according to our Pythagoras theorem, hypotenuse is square. We will place the values of base unit 1 square, plus we will place the value of perpendicular unit 1 square. So h square is equal to 1 square, answer is 1, and another 1 square, answer is 1. So h square is equal to 1 plus 1 is equal to 2. H is equal to this square, it moves out into square root. So under root 2 or square root 2 is our answer as hypotenuse under root 2. So now we will raise this line. The similar as you are taking the distance from 0 to 1, similarly the distance you have to draw with the help of protractor from here, as similar distance you have to mark at 90 degree. Now you will draw the line till here and take an arc of similar distance and move this arc with the help of compass. Here what we will be having, this is the mark of under root 2. This is 2. This is unit 3. So same manner, this is the value we got under root 2. Now here we are having base as under root 2. Again we will draw one unit perpendicular on it. Then we will move to the Pythagoras theorem. So what we are having, see, we need to find out the hypotenuse, h square. Base, we are having under root 2. So here we will do the square of under root 2 plus perpendicular we are having 1 unit. The similar as we have drawn here. The similar distance we need to take as perpendicular. So unit 1 square. Under root 2 square is answer 2 plus 1 square, answer is 1. So h square is equal to 3. Here we will get root 3 as hypotenuse. So now we will draw the distance from here to here. So the hypotenuse answer we are getting as under root 3. Similarly, we will take the arc of this distance and we will draw it to the number line. We will get the answer as under root 3 on the number line. So in this manner, we are drawing the irrational numbers on the number line. Some other numbers are there in which what you have to do, if you are knowing the Pythagorean triplet very well, then it will be very easier for you to draw or to locate these irrational numbers on the number line, and which will be very easier for you to know the Pythagorean triplet. We only want to get our irrational number as hypotenuse. So in this manner you can locate all these irrational numbers on a number line. I hope you understood. Next we are having some more sums for it related to this chapter exercise, to solve exercise 1.2, as we are having like question first. Represent 3.15263 in the form of P upon Q, or else we will be having question as 3.15265. Show that 3.15265 is a rational number. Very easier for us. Firstly, if you want to go through the definition, then you can say that one, it is terminating, that's why it is rational number. You can see we are having 3.15263 and it is terminating. It is not continuously giving the answers, we are not getting the values